Primary School Math Olympiad Challenge 1. This is a sample paper to help one prepare for the Primary School Math Olympiad. There are 30 questions. Challenge yourself to complete within 2 hours, please. If you can't achieve it the first time, do not be disheartened. However, with practice, and if one works hard and revise this sample paper multiple times, one should be able to complete this challenge within 2 hours. Question 1. Which or below when folded create the cube on the right? Question 2. John drove from town A to town B at a constant speed of 90 km per hour. However, mid-journey he encountered heavy snowfall and decided to turn back. He drove at a slow constant speed of 60 km per hour back to town A. What was John's average speed for the whole journey? Question 3. The chocolate factory produces 20% more chocolate bars in the second year compared to first year. But production in the third year is 10% less than in the second year. What is the difference in percent between third year and first year production? Question 4. The diagram comprises a quarter circle with radius of 7 centimeters. Within the quarter circle is a rectangle. Half of the rectangle is shaded. Find the area of all the shaded parts. Pi equals 22/7. Question 5. A equals squared root of 2, B equals cubed root of 3, and C equals 6 to the power of 1/6. Arrange the value of A, B, C from lower value to higher value. Question 6. A parallelogram is folded along the two farthest corners. The ratio of total area after the folding versus the original parallelogram area is 7:9. The overlapping area formed the shaded area, which is 18 centimeters squared. What is the area of the original parallelogram? Question 7. O is the center of the circle. Line A is 6 centimeters from O. Line B is 3 centimeters from O. Line A and B are perpendicular lines. Find the difference between shaded and unshaded areas. Question 8. Value of n equals value n minus 1 plus value of n minus 2. The value of n equals 1 is set as 1. Thus value of n equals 2 equals value of 1, which is 1. Value of n equals 3 equals value of 1 plus value of 2, which is 1 plus 1 equals 2. Thus the value of n equals 4 equals 2 plus 1 equals 3, and so on. If the value of n equals 3001 is divided by 2, what is the remainder? Question 9. The diagram comprises a triangle and a semicircle. AD equals DB equals 28 centimeters. E is the midpoint of DB. Find the area of the shaded region. Pi equals 22/7. Question 10. John arranges 50 boxes in a row and numbers them 1 to 50. He started allocating marble into the 50 boxes. In round 1, he put 1 marble in box 1 to 50. In round 2, he checked only the even number box and removed the marbles. In round 3, he checks boxes which are multiple of 3. If the box has marbles, he removes it, and if it is empty, he places 1 marble in the box. He does the same approach from round 4 to 50. What is the total number of marbles in the boxes after round 50? Question 11. 42y323553424449. What is the value of y in order the number is divisible by 11? Question 12. Find the simplest form of the equation. Question 13. There are 4 points on the circle as shown. How many triangles can be formed by joining any of the 3 points? Question 14. Mary has 56 sweets. On day 1, she eats 1/8 of the sweets. On day 2, she eats 1/7 of the remaining sweets. On day 3, she eats 1/6 of the remaining sweets. On day 4, she eats 1/5 of the remaining sweets. On day 5, she eats 1/4 of the remaining sweets. On day 6, she eats 1/3 of the remaining sweet. How many sweets are left after day 6? Question 15. Find the value of the equation. Question 16. Split the number 20 into two numbers. For example, split 20 to y and z, thereafter have y times z added into an accumulated score. Continue the same splitting process for y and z until all numbers are 1. What is the largest possible accumulated score at the end of the process? Question 17. Equation 3 to the power of 30 is equal to 20x891132094644y. What is the value of x and y? Question 18. The diagram comprises two similar-sized semicircles AGH and AEF, and a circle AIDJ in the middle of the diagram. All of them have a diameter of 6 centimeters respectively. ABC is an isosceles triangle with BC equals 7 centimeters. Find the size of the shaded area in centimeters square. Pi equals 22/7. Question 19. The clock is at 9:18 a.m. What is the angle between the hour hand and the minutes hand? Question 20. Triangle ABD is divided into 4 regions by line BE and AC. 3 of the region values are as shown. What is the value of y? Question 21. What is the value of 1 cubed plus 2 cubed plus 3 cubed up to 20 cubed? Question 22. ABCDE is a regular pentagon with an area of 10 centimeters square. The area of BCH equals 1.04 centimeters square. Find the shaded area DFG in centimeters square. Question 23. After a football game, all 11 players put both their boots in one bag and their socks in another bag. All the boots and socks have the player names stitched to them. First you start to take out one boot at a time randomly from the first bag, and then later one sock at a time randomly from the second bag. What is the largest number of boots and socks one might have to take out from the bag to get at least one pair of boots and one pair of socks worn by the same player? Question 24. An engine has 3 gears connected as shown. The large gear has 80 teeth, the mid-size gear has 32 teeth, and the small gear has 16 teeth. If the large gear rotates 90 degrees, what is the corresponding rotation degree of the mid-size gear and small gear? Question 25. ABCD is a rectangle. APSD is a square. Length of AP, PQQR and RB are the same. Angle BSC equals 25 degrees. Find the sum of angle DPS, angle DQS, and angle DRS. Question 26. John and Mary had a cycling race. John, who is a faster cyclist, allowed Mary to start at 6 a.m. John started the race at 6:15 a.m. If John's cycling speed is 12 kilometers per hour and Mary's cycling speed is 10 kilometers per hour, at what time did John catch up with Mary? Question 27. Y is a positive integer. How many possible values of y less than 2011, which are divisible by neither 3 nor 7? Question 28. Brian, John, and Tony work at their respective constant rate to complete a task. If Brian and John work together, the task is completed in 2 hours. If Brian and Tony work together, the task is completed in 1 hour and 12 minutes. If John and Tony work together, the task is completed in 1 hour and 30 minutes. If Tony works alone, how long does he take to complete the task? Question 29. ABCD is a square. Side length is 4 centimeters. AR to RB equals 1 to 3. Find the area of the shaded region in centimeters squared. Question 30. Anna and Mary raced from point A to B at different constant speeds. The distance between A and B is 7 kilometers. Upon reaching point B, they cycled back toward point A at double their running speed. Anna reached point B first and immediately cycled back to point A. Anna met Mary at 0.7 kilometers from point B. When Anna reached point A, how far was Mary from point A? Answer for question 1. The answer is all of them. If you are not sure, use a piece of paper and tear into the above shapes and test them. Answer for question 2. Let's find the common multiple for the two-speed John was traveling, which is 90 km per hour and 60 km per hour. The obvious one is 540. Please note that you do not need to find the smaller common multiple for the two numbers. Choose the obvious 1 and 1, that is easy to use later. For ease of understanding, we plotted the data in the diagram on the right. You will find that the total distance traveled by John is 540 times 2, which is 1080 kilometers. The time taken by John for the entire journey is 540 divided by 90 kilometers per hour when he was traveling toward town B, and 540 divided by 60 kilometers per hour when he was traveling back to town A. Work out the equation, and the total duration for the entire journey is 15 hours. Average speed is therefore equal to total distance traveled, which is 1080 kilometers divided by duration taken, which is 15 hours. Work out the equation and the answer is 72 kilometers per hour. Answer for question 3. For ease of calculation, let's assume the first year production is 100 chocolate bars. Given that the second year production is 20% more than first year, thus second year production is equals 100 times 1.2 and equal to 120 chocolate bars. Given that the third year production is 10% less than second year, thus it is equals 120 times 0.9 equals 108 chocolate bars. The third year production is 108 minus 100, which is 8 more than first year, or 8 over 100, which is 8% more. Answer for question 4. Shift the shaded part of the rectangles as shown on the diagram. The shifted shaded part, combined with the not shifted shaded part, to form a partial circle of 30 degrees, with radius of 7 centimeters. Thus shaded part equals area of the partial circle of 30 degrees. Work out the equation. The answer is 12 and 5 over 6 centimeters squared. Answer for question 5. The lowest common multiple for 2, 3 and 6 is 6. Work out the equations for A, B, and C to the power of 6. You will see the order from lower value to high value is C, A, B. Answer for question 6. Assume A is the area of the original parallelogram. The ratio of total area after folding versus original parallelogram is 7 to 9. As such, the folding lost 2 over 9 of the parallelogram area, which is equal to the overlapping areas or shaded area. Given 2 over 9 of A equals 18 centimeters square, thus A equals 81 centimeters squared. Answer for question 7. Add a vertical line 6 centimeters from O and a horizontal line 3 centimeters from O as shown on the diagram. X and X prime, Y and Y prime, Z and Z prime cancel each other out. The difference between the shaded and the unshaded areas is the square in the middle, which is 6 centimeters times 12 centimeters. The answer is 72 centimeters squared. Answer for question 8. The table shows the remainder of the equation for values of n equals 1 to 9 when divided by 2. From the table, the remainder of the equation divided by 2 is 1, 1, 0, 1, 1, 0, and so on. The remainder of 1, 1, and 0 repeated itself every period of 3. Divide 3001 with the period of 3. We have 1000 with the remainder of 1. Thus the value of n equals 3001 divided by 2 will have a remainder of 1. Answer for question 9. Add the red dotted lines. Name the two areas Y and Z. Area Z equals half times the length of FC, which is 28, plus 14, then times length of AF, which is 28 divided by 2. Solve the equation. The result is 42 times 7 centimeters square. Let's keep the result as multiple of 7 for ease of calculation later. Area Y equals quarter circle DEC minus triangle DEC. Work out the equation. You have 8 times 7 centimeters squared. Shaded area equals area of ADEF plus quarter circle DEC minus Y minus Z. Work out the equation. Your answer is 196 centimeters squared. Answer for question 10. We sample a few boxes as shown to see the number of rounds John visited the box. Box 1, 4, 16, and 25 were visited 1, 3, 5 and 3 times respectively. All are odd numbers. Thus they will have marble at round 50. Notice that 1 is 1 square, 4 is 2 square, 16 is 4 square and 25 is 5 square. Box 2, 15, and 18 were visited 2, 4 and 6 times respectively. All are even numbers. Thus they will not have marble at round 50. Thus the answer to the question is that box 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, and 7 squares still have marble at round 50. Total marble left is 7, since each box has 1 marble. Answer for question 11. Based on the divisibility rules, a number is divisible by 11 if the sum of the digits in the odd places and the sum of the digits in the even places difference is a multiple of 11 or 0. Sum of digits in odd places for the number equals 29 plus y. Sum of digits in even places for the number equals 25. The difference between the sum of odd and even digits is 4 plus y. 4 plus y is multiple of 11 if y equals 7. Thus the answer is 7. Answer for question 12. Notice the numerator is a multiple of 1001 and the denominator is a multiple of 2002. Simplify both the numerator and denominator respectively. You have the numerator equals 1001 times the result of the terms 1.0001 plus 10,001 plus 0.001 plus 0.01 plus 2.0002 plus 40,004 plus 0.004. Denominator equals 2002 times the result of same terms as the numerator. The terms of 1.0001 plus 10,001 plus 0.001 plus 0.01 plus 2.0002 plus 40,004 plus 0.004 in the numerator and denominator cancel out each other. The equation is now equals 1001 over 2002. The simplest form of the equation is 1 over 2. Answer for question 13. See the diagram. The number of triangles that can be formed is 4, since none of the points are collinear, meaning any 3 points can form a triangle. Thus the answer is 4. If there are more points on the circle, it will not be possible to use the same approach. Assuming you have n points, given you can use any 3 points to form a triangle. The number of triangles can be calculated using the combination formula of NC3 as shown. Using the formula, if n equals 4, the number of triangles equals 4. Using the formula, if n equals 5, the number of triangles equals 10. Answer for question 14. On day 1, the number of sweets eaten equals 1/8 of 56 equals 7. There are 49 sweets left. On day 2, the number of sweets eaten equals 1/7 of 49 equals 7. There are 42 sweets left. On day 3, the number of sweets eaten equals 1/6 of 42 equals 7. There are 35 sweets left. Notice Mary eats 7 sweets per day. Thus after 6 days she has eaten 42 sweets. Hence the number of sweets left after day 6 equals 56 minus 42. The answer is 14 sweets. Answer for question 15. Break up the denominators of the fractions in the equation, as shown. 27 equals 3 times 9, 243 equals 9 times 27, 2187 equals 27 times 81. Derive the equation further. 1 over 3 times 9 is equal to 1 over 3 minus 1 over 9. 1 over 9 times 27 is equal to 1 over 9 minus 1 over 27. 1 over 27 times 81 is equal to 1 over 27 minus 1 over 81. The fractions cancel each other out, except for the first one and last one. Thus the remaining fractions are 1 over 3 minus 1 over 81. The answer for the equation is 26 over 81. Answer for question 16. Imagine each number 1 to 20 is a marble and connected to each other by a thread. The splitting will break the thread. For example, if split 20 into 10 and 10, it will break 10 times 10 equals 100 of such threads, as the 10 marbles in one pool will get disconnected from the 10 marbles from the other pool. As such, the number of threads disconnected is fixed and independent of the approach to split the number. Assuming we disconnect one marble at a time, thus the accumulated threads disconnected will be 19 plus 18 plus 17, and so on as shown on the diagram. Thus the largest accumulated score equals sum of 1 to 19. Work out the equation and the answer is 190. Answer for question 17. Notice the last digit of 3 to the power of 2 onward repeats itself, in sequence of 9, 7, 1, 3. Excluding 3 to the power of 1, we have 29 divided by 4, which is 7, with remainder of 1. Thus y equals 9. The total of digits, 2 plus 0 plus x plus 8 plus 9 plus 1 plus 1 plus 3 plus 2 plus 0 plus 9 plus 4 plus 6 plus 4 plus y, is a number divisible by 9. Add up all the known digits, you have 49. Replace y with 9, you have 58 plus x. X is equal to 5, in order for 58 plus x to be divisible by 9. This gives a value of 63. Thus 3 to the power of 30 is equal to 2, 0, 5, 8, 9, 1, 1, 3, 2, 0, 9, 4, 6, 4, 9. Answer for question 18. Add the dotted red lines. Semicircle AGH and AEF overlap the circle AIDJ for the area surrounded by the dotted red lines. As such, the combined size of semicircle AGH and AEF minus the area surrounded by the dotted red lines is the same as circle AIDJ minus the area surrounded by the dotted red lines. Thus we can move the shaded area from within semicircles to within the circle. The shaded area, now the size of triangle ABC, equals 7 times 6 times half. The answer is 21 centimeters square. Answer for question 19. Let's first find the angle between the hour hand to 9. Since the degree between 9 to 10 on the clock is 360 degree divided by 12 equals 30 degrees. Thus we have 18 minutes divided by 60 minutes times 30 degrees. The result is 9 degrees. For the angle between the minutes hand and 9, the angle between 3 to 9 o'clock is 180 degree. The angle between minutes hand to 9 is 4 after 9:18 a.m. Thus the angle between the minutes hand and 9 equals 30 minus 3, then divided by 30, then times 180 degrees, which is equals 162 degrees. Thus the angle between the minutes hand and hour hand equals 9 degree plus 162 degree. The answer is 171 degree. Answer for question 20. Add the dotted red line, which divides region Y into S and R. S plus R equals Y. Triangle ABE is divided by AF into two equal parts of 9. This means F is the midpoint of BE. As such, triangle BCE is also divided by FC into two equal parts. Thus S equals 3. Triangle ABD is divided into two parts by line BE. Triangle ACD is divided into two parts by line CE. Given triangle ABD and triangle ACD are both divided at point E on line AD. As such, the ratio of 9 plus 9 over S plus R plus 3 in triangle ABD is equal to the ratio of 9 plus S over R in triangle ACD. Replace the value of S with 3. Solve the equation. The result is R equals 12. Y equals S plus R equals 3 plus 12. The answer is 15. Answer for question 21. The value of 1 cubed is equal to 1 squared. The value of 1 cubed plus 2 cubed is equal to 3 squared or bracket 1 plus 2 closed bracket squared. The value of 1 cubed plus 2 cubed plus 3 cubed is equal to 6 squared or bracket 1 plus 2 plus 3 closed bracket squared. Therefore, the value of 1 cubed plus 2 cubed plus 3 cubed up to 20 cubed is equal to bracket 1 plus 2 plus 3 plus 4 up to 20 closed bracket squared. You can derive the sum of a series of numbers up to the value of n using the above formula. Applying the formula for 1 plus 2 plus 3 plus 4 up to 20, which is equal to 20 multiplied by bracket 20 plus 1 closed bracket divided by 2, which gives the value of 210. 210 squared will give you the value of 44,100. This should be your answer. Answer for question 22. ADE equals ADH equals BCD equals ABC. However, BCD overlaps ABC with an area size of BCH. As such, 4 times CDE equals pentagon ABCD plus BCH. Work out the equation. You have CDE equals 2.76 centimeters square. Given DEF equals GDC equals BCH equals 1.04, thus DFG equals CDE minus 2 times 1.04. Work out the equation. The area of DFG is 0.68 centimeters square. Answer for question 23. Let's start with the boots. Assume the random take-up keeps getting 11 different players' boots. Thus the boots taken out equals 11. Then for the 12th takeout, we have one pair of boots worn by the same player. Let's call it play A. Thus boot taken out equals 1. Next we take out the socks. Assume the random take-up keeps getting 11 different players' socks. Thus socks taken out equals 11. Then for the next 10 takeouts, we keep getting the socks of other players and not the ones worn by player A. On the 11th try, player A's sock was taken out. Thus socks taken out equals 11. The largest number of boots taken out are 12 and socks are 22. Thus the total is 34. There is another approach. Let's start with the boots. All 22 boots are taken out. Next we take out the socks. Assume the random take-up keeps getting 11 different players' socks. Thus socks taken out equals 11. Then for the next takeout, we will definitely get one pair of sock from the same player and with the player boots already taken out. Thus sock taken out equals 1. The largest number of boots taken out are 22 and socks are 12. Thus the total is 34. Answer for question 24. For rotation of 90 degrees in the large gear, it is represented by 90 degrees divided by 360 degrees, then times 80 equals 20 teeth. Correspondingly, the mid-size gear will also rotate the degree of 20 teeth, which will then lead to the small gear to rotate the degree of 20 teeth. Thus the degree of rotation for the mid-size gear equals 20 divided by 32, then times 360 degrees. The answer is 225 degrees. The degree of rotation for the small gear equals 20 divided by 16, then times 360 degrees. The answer is 450 degrees. Answer for question 25. Angle DPS equals angle PDA as shown by the dotted red lines. Angle DQS equals angle PDQ as shown by the dotted red lines. Angle DRS equals angle QDR as shown by the dotted red lines. As such, the sum of angle DPS, angle DQS and angle DRS equals sum of angle ADP, angle PDQ and angle QDR, which is equals to angle ADR. Angle ADR is equal to angle ADS minus angle RDS. Given APSD is a square, thus angle ADS equals 90 degrees. As such, angle ADR equals 90 degrees minus angle RDS. Given the length of AR equals PB, thus angle RDS equals angle BSC equals 25 degrees. As such, angle ADR equals 90 degrees minus 25 degrees. The answer is 65 degrees. Answer for question 26. Since Mary started at 6 a.m., thus at 6:15 a.m. Mary was already cycling for 15 minutes at 10 km per hour. 15 minutes is equal to 0.25 hour. Thus Mary was 2.5 kilometers ahead when John started at 6:15 a.m. The 2.5 kilometers is derived by a 0.25 hour multiplied by 10 kilometers per hour, which is the speed of Mary. John's speed of 12 kilometers per hour versus Mary's speed of 10 kilometers per hour is 2 kilometers per hour faster than Mary's. It means John takes 1 hour to catch up 2 kilometers against Mary. As Mary is 2.5 kilometers ahead, thus John took 2.5 kilometers divided by his catch-up speed of 2 kilometers per hour, which is 1.25 hour or 1 hour 15 minutes, to catch up with Mary. Therefore John caught up with Mary at 6:15 a.m. plus 1 hour 15 minutes, which is 7:30 a.m. Answer for question 27. The possible number less than 2011 divisible by 3 equals 2010 divided by 3 equals 670. The possible number less than 2011 divisible by 7 equals 2010 divided 7 equals 287. The remainders are ignored. The possible number less than 2011 divisible by 3 times 7 equals 2010 divided by the result of 3 times 7 equals 95. These are numbers counted in both the divisible by 3 and 7. Thus the value of y less than 2011, not divisible by 3 or 7, equals 2010 minus 670 minus 287 plus 95. The answer is 1148. Answer for question 28. Let B, J and T be the time in minutes taken by Brian, John and Tony to complete the task, if they work alone respectively. Their work rate per minute is 1 over B, 1 over J and 1 over T. 1 over B plus 1 over J equals 1 over 120. This is equation 1. 1 over B plus 1 over T equals 1 over 72. This is equation 2. 1 over J plus 1 over T equals 1 over 90. This is equation 3. Equation 1 plus equation 2 plus equation 3 equals 2 over B plus 2 over J plus 2 over T equals 1 over 120 plus 1 over 72 plus 1 over 90. Solve the equation. You have 1 over B plus 1 over J plus 1 over T equals 1 over 60. This is equation 4. Replace equation 1 into equation 4. Solve the equation. You have 1 over T equals 120. Thus T equals 120 minutes equals 2 hours. Answer for question 29. For ease of understanding, Let's label the rest of the joints. Let AS equals Y. Thus ST equals Y, and SR equals AR minus Y equals 1 minus Y. Given AD equals 4, AR equals 1. Given triangle SRT and ARD are similar but different sizes. Thus ratios of SR to AR equals ST to AD. As such 1 minus Y equals Y over 4. Work out the equation, you have Y equals 4 over 7. Shaded region equals size of ASTU plus RWV plus TWC. Work out the equation. The answer is 7 and 3 over 49. Answer for question 30. Let VA be the speed of Anna and VM be the speed of Mary as shown on the diagram. VA over VM is the distance both travel for the same duration. The distance Anna travels for the same time, when Mary travels 6.3 kilometers, is 7 plus half of 0.7 equals 7.35. The half of 0.7 is because Anna was moving twice the speed of VI when cycling. Solve the equation, you have VA equals 7 over 6 of VM. This is equation 1. The time taken for Anna to reach point A equals 7 divided by VA plus 7 divided by 2 VA, which is equal to 10.5 over VA. During the same time, Mary reached the distance of Y from point B. Thus the same time is equal to 7 divided by VM plus Y divided by 2 VM. Combine the two equations as shown. Thereafter replace the value of VA from equation 1. Solve the equation, you have Y equals 4 kilometers. Thus Mary was 7 minus Y equals 7 minus 4 equals 3 kilometers from point A. Thank you for watching. Please like and subscribe.